Hey everybody, this is Larry. This is day 23 of the Leetcode Day Challenge. If it wants to load, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Today I ran 6 miles in Central Park. It was pretty good. It's my attempt to do what I call tempo run. It is basically my marathon pace from a year ago, or less than a year ago really, but half a year ago. Except for this time, I'm still exhausted. So exhausting. And yeah, that was pretty much it. And I just slept a lot. It was good. It was a good day in terms of didn't get more injured and stuff. And that's it. All right. Yeah. Without further ado, today let's take a look at today's problem. We have 1976 number of ways to arrive at destination. Okay, let's read it. Direction number and the shortest amount of time. The numbers can be big, so you have to mod it. All right, let's do the mod real quick before I forget. But this is going to be dynamic programming, right? I know it's kind of also shortest path, but the idea here is just to use Dijkstra. Is it directed? No, but yeah, it's just Dijkstra. The idea here is that you in the shortest amount of time, if you kind of think about it in terms of greedy, it's the first time you get there. But also, you just have to and this is dynamic programming in a way. You have to think about how everything kind of comes together. Is that the number of ways to, there's a very recursive way I'm saying this right now, which is kind of like dynamic programming in terms of subproblems, right? Which is that if I'm able to get to this node at X time, what is the, how many ways are there to get to X node in T time if given all these other previous nodes in other times, right? And that's really the idea here. Yeah, let's see. Where are we going? From 0 to n minus 1? Is that it? Okay. So here, yeah. We'll just go right into it. This is heap, but we also want to do like a best. Oops. Bet. Right. I don't know what the big number is, but yeah. And then maybe like a count as you go to 0 times n, right? Something like that. And then now the modification. I think one thing that it may come off as is that honestly, I have seen this problem before, right? I think sometimes people kind of ask me and some problems I haven't seen exactly, but I've also seen similar ones. I don't know if I've seen this exact one, but it's similar. But I think what I would like the takeaway for you is just think about the relationship between all these problems and try to figure out how to come up with it. I would say independently, but. And I think the first time I saw it, I do remember just trying to figure out the reasoning behind it, right? And the dynamic programming's idea, or the idea of overlapping subproblems. But yeah, maybe English is fine too. I don't know. But yeah, so we have to set best of 0 to 0, and then count. There's only one way to start with one at node 1, so we'll do that. Right, so here we want to say, what is it, distance? Node is equal to heap q dot heap pop of h. Yeah, right. And then we have, and this is just where I could, oh man, I'm going too fast. I forgot to actually pause the roads. So let's do that to an adjacency list. Oops. Right. No big deal, right? And of course with binary with Dijkstra's algorithm, we talked about it yesterday, right? So here what we don't want to do, because we would update heap, is that we don't want to process when we process a node, when we relax a node, it, by definition of greedy, it is the shortest path there. There's no future path to go back to this node in which it'll be better. Of course, that's why dice draw only works with positive edges, right? Or non-negative if you want to be precise. Because otherwise, if you have negative edges, you have negative. If you have negative edges, then that's not true because you may go to a node where in the future you can go loop back in a cheaper place. And of course, even negative cycles, but that's another thing, right? So what you can do is, of course, just say that right? And it may seem like an optimization, and it is, I suppose, but it also, if you don't do it, it may give you TLE as a result because of how. If you want to write it out, then just draw out the path of dice drawers and why that is. But yeah, otherwise, then for v in vw in adjacency list of the current node, we want to say if best of v is greater than the current distance, which is best of the node plus w. Then we set best of node plus w, best of v is equal to and of course, then now how many ways are there to get there from this path? Well, it's just going to be this, this path, right? Because that's just the number of ways to get from here, right? But there is a wrinkle, which is that if they're equal, then what does being equal mean, right? Well, being equal means that and you could draw very simple graphs for stuff like this, where, for example, you have just like a diamond graph, right? And for something like a diamond graph, and all the edges are 1, then it becomes a little bit more clear, because then now you just kind of merge at a node, and of course they're 2 distinct ways, so you just kind of add them together. So here you don't have to, you don't have to do anything more than this. And that's really the idea, and that's really much it. I mean, obviously we have to actually push it onto the heap, but that's basically the idea, right? Am I forgetting something? No, maybe not. I don't know. I mean, if I am, we'll find out, I guess. But yeah, and then now we just return count of and I mean, we should mod. I think I forgot to mod. Here we can definitely mod, but we should also mod when we add, right? Because that's the only case where it gets bigger. And yeah, hopefully I didn't miss something silly, and looks good. And again, I'm not gonna go over dice drawers today, just because I don't know. I mean, I want to go over the new applications of it. But yeah, that's why. But yeah, that's what I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.